All right, so sorry about that. I forgot to hit record, but I am recording now for the YouTube people. So we're looking at factoring trinomials, which will give us two binomials. And like I just mentioned, it's like solving a little puzzle. I need to find two numbers that are going to multiply to give me 30 here and then add to give me 11. So what you need to do is you need to think of the factors of 30. So there's 1 times 30. That's obviously not the answer, but that's two of the factors of 30. There is 3 times 10 and 6 times 5. So 6 times 5 seems to be the answer. Six times 5 will give us 30. 6 plus 5 will give us 11. So what the book here says to do is to make a table of possibilities. Here is 1 times 30, 2 times, oh, I forgot 2 times 15, 3 times 10, 5 and 6. And 5 and 6 seems to be the answer. They do add to give us 11. So this is where my binomials come from. I know this seems a little weird. You'll see me do a couple of examples in a minute. It's a lot easier than it looks. So what about this example? It says factor x squared minus 3x minus 40. So what do I do? Oh, sorry, there's I don't want to say a typo here, but there's like a difference. So it's this should be negative 18. So this one says, so again, guys, I'm solving this with the 18 put in there, not the 40. It's a little typo there. It says x squared minus 3x minus 18. So what I need to do is I need to find two numbers that are going to multiply to give us minus 18 and add to give me minus 3. These numbers in here. Well, okay, so let's think of the multiples of 18. You can see it in this table here. And again, it's a negative 18, so you got to be careful with this one. So I have 1 and negative 18, negative 1 and positive 18. There's positive 2 and negative 9, negative 2 and positive 9. So you can see I'm coming up with different combinations of numbers that are going to multiply to give me a negative 18. And I notice that positive 3 and negative 6 multiply to give me a negative 18, and they add to give me a negative 3. So there's my answer. I have a positive 3 and a negative 6. So there's my two binomials that multiply together to give me this trinomial. Kind of weird, like this is a little bit different than what we've done in math before. There is like a set trick to doing this. It's kind of like solving a little puzzle. So someone in the chat says, do we have to make the table in the test and final exam? No, you don't have to show me this table. I mean, you can do it, but you don't have to. You can do whatever you want, really. You don't have to show me this if you don't want to. So let's look at another one. There's 3 examples here. And then I think, yeah, okay, I'm going to get you guys to practice some of this. So what about this example? So x squared minus 14x plus 24. So I need to think of two numbers that are going to multiply to give me 24. Oops. And add to give me negative 14. So again, you don't have to write this down, but you think of these numbers. So two numbers that are going to multiply to give me a 24 and add to give me negative 14. So there's obviously negative 1 and negative 24. Or positive 1 and positive 24. Sorry. They're not going to add to give me 14. So they're not good. Negative 2 and negative 12. Now, so negative 2 times negative 12 is negative is a positive 24. And when I add them together, I get a negative 14. So yeah, that does work. So there's my answer. It's kind of hard to teach or to explain because it's like I said, it's like solving a little puzzle. Like for example, if you look at number A here, I need to find a number that's going to multiply to give me 6 and add to give me 5. Well, the easy answer for that one is 2 and 3. 3 times 2 is 6. 3 plus 2 is 5. So sometimes, like question 1a, they can be really, really simple. Sometimes when you get like negatives, like if you look down at F or E, they can be a little bit more challenging. So I'd like to give you guys a couple minutes to try this. See what you can do. You can try as many as you want. I definitely would do F and E. But yeah, try as many of these as you can. You can also do, I mean, you can do them all if you have time. See if you can figure out the factor for each of these. Now, just a reminder, it's always going to be X and something, and then X and something. So when you factor a trinomial, it will give you two binomials. So it's going to be like X plus something or X minus something, and then X plus something and X minus something. All right, so give these a try. Let me know in the chat if you have any answers. You can try B, C, D, E, and F, and we'll be back, or I'll be back with the answers in a few minutes. Good luck, everybody. I just want to, like Hoda just shared the answer for B. I think you're correct. X plus 2 and X plus 8. That looks good to me. 8 times 2 is 16. 8 plus 2 is 10. Yeah, that's good. So keep going. All right. I'm getting lots of good answers in here, so let's check it out. And Matab have given me a few. Dustin, let's look. Okay, so question C, um, positive 12 and negative 4. Now, if you're just joining me, just remember, it's kind of like solving a puzzle. I'm trying to find two numbers that, let me zoom in a little bit, that multiply to give me 12 and add to give me negative 8. So multiples of 12 are like 2 and 6, 3 and 4, and 1 and 12. So what do people say here for C? X minus 2 and X minus 8? Yeah, that's it. By the way, I never mentioned this earlier, but you can always check your answers by solving this or expanding this. So like going back through your work. So X minus 2 and X minus 6, if you want to check this, well, first of all, negative 2 times negative 6 is positive 12, and negative 2 plus negative 6 is negative 8. So you might want to use a calculator for this, but you can always go back and check. And this is like one of my favorite things about math is you can, most of the times in this course, you can check your answer. So what I can do is I can double distribute, or, we would call this foiling, first outside, inside, last. So x times x is x squared. X times a minus 6 is a negative 6x. Negative 2 times x is minus 2x. And then negative 2 times negative 6 is plus 12. So this works, right? This gives me my answer. So you can always check your answers. Or I shouldn't say always, but for a question like this, you can check this, which I really like about math. So what about D? We have x squared minus 9x plus 14. So I need to think of the multiples of 14. There's 1 and 14. There's 2 and 7. That seems about right. And I think that's it. Yeah. So this one here would be x minus 2 and x minus 7. All right, let me check the answers, see if people got that in the chat. Yes, okay, cool. So you guys are doing pretty good with this. All right, so E and F, what about E? Negative 15. Let's think of the multiples of that. I think 5 and 3 are going to work here. That's kind of where I start when I do this. I think of I don't worry about negatives and positives. I think of combinations of numbers that are going to work. I don't think about positive or negative. So 5 and 3 will somehow make me a 2. So for this one, for 15, I guess I'll just do it right here. We would have x minus 2, or sorry, minus 3. Oops, sorry, my pen's going a bit weird. Hold on, let me fix my pen. Okay, sorry about that. So x minus 5 and x plus 3. So 3 times a negative 5 is negative 15. Negative 5 plus 3 is a minus 2. How do you guys feel about this? Does this make sense? Is this confusing? What do you think? Oh,
Good.
and I have a message from a student. I'll say her name. Khalid is asking me a question. When will the class end? Because you have a lab at 11:30. Um, make sure, because this is recorded on YouTube, make sure you guys make it to your lab. Don't like ever stay late to math because you have a lab. So hopefully this class will end at around 11-ish or 11:10. But if you guys have a lab to go to, get to that lab. Don't be late for your lab because of math. Just remember, like anything you miss, you can watch on YouTube after. Okay, what about F? So, did anybody answer F? Yeah, I got one student answered F. So 30, negative 32 and 4. So again, think of the multiples of 32. There's 1 and 32, 2 and 16, 4 and 8 seems about right. I know I can add together 4 and 8 somehow to get a negative 4. So my again, like what I'm doing, guys, is I'm thinking of multiples of 32. So 1 times 32, 2 times 16, 4 times 8. I know 4 and 8 will be somehow my answer. What I need to do now is think about which will be positive and which will be negative. Because if you add 4 and 8, you're going to get 12, which is obviously not the answer. So this one would be x plus 4 and x minus 8. Positive 4 plus a negative 8 is a negative 4. Positive 4 times a negative 8 is a negative 32. Again, a little weird to kind of teach you because it is like solving a puzzle. But yeah, so there you go. That's it. You guys can try more of these. I highly recommend practicing some of this. Like you could see for I, we have 100. So 10 times 10 probably would be the answer. I'll kind of leave it at that. All right. So any questions before I move on? Okay. So some trinomials will be a little bit more complicated than the ones we were looking at, meaning sometimes we might need to factor them before we even get started. I know, I guess that kind of sounds confusing. Um, we are factoring these, but sometimes we can simplify them a little more before we get started. So if you look at example number 1 or example number 2 here, so there's example 1, there's example 2. These all have a GCF, a greatest common factor, that I can remove first, and then I can follow my steps like normal. So in example number 1, so I'm up there, example number 1, I can remove a 2. I can factor out a 2 before I even get started. This is simplifying this by removing the 2. It becomes a little more straightforward. One thing I'll mention here, guys, is just look at where my pen is in the middle. This negative x is a negative 1. We don't always write 1 in math, which you've heard me say like 50 million times this semester. So x squared minus x minus 12, this trinomial here, we're looking for two numbers that multiply to give us a minus 12 and add to give us a negative 1. Even though there's not a 1 there, we assume that it's there in math. So the answers for this one are 3 and 4. If you look at example number 2, we factor out a 5. Actually, sorry, for number 2, we can factor out a 5x, not just a 5. We remove the 5x, and then what remains, where you can see me circling with my pen here, is pretty straightforward. X squared minus 4x plus 3. Now, that's an interesting one, isn't it? Two numbers that multiply to give us 3. There's only two numbers I can literally think of, 3 and 1. So the answer here becomes a negative 3 plus a negative 1 will give us a negative 4. Right? This is what I'm looking for, this negative 4. Negative 3 times negative 1 is a positive 3. So there you go. So why don't you guys try these? I know, I hope I'm not going too fast or anything, but I'd like for you guys to try these. Start by removing a GCF. So like let's look at example A for practice. In example A, I have 3x cubed, 21x squared, and 18x. So this one's a little bit tricky. I need to think of a number I can remove from all of these. Well, all of these numbers, first, I could remove an x. The other thing I notice is that all of these are multiples of 3. So I can start question A. Oops, oh, sorry, guys. I didn't mean to skip down there. I can remove a 3x. Okay, so I'm going to remove a 3x from all of these, and what I'm left with is x squared minus 7x, and what's the next one? Plus 6. And now I can factor this guy like normal. I'm trying to find
-1 -6.
Yeah. Oh, -1 minus 6. Sorry, is that your answer?
Yes, it will be x -1, x -6. And the next step,
Yep, you're correct. Yeah, that took me a minute, right? Like, so I've been teaching this for like, gee whiz, I don't know, 10, 11 years. Yeah, that's right. It took me a minute for my brain to like make the connection, but yeah, x -1, x -6. All right, so why don't you guys try these? Why don't you try B, C, and D and solve these? Sorry, and I just put the answer up for A. I didn't write it down. I was like talking, but yeah, x -1, x -6. That's a tricky one. Or that was tricky for my brain anyways. So yeah, try B, C, and D, and we'll check your answers in a minute. All right, so there's some really good answers here. Let's check them out. So remember, for these questions, I'm starting by removing a GCF. So like for B, I think B is a pretty kind of easier one than say like D, for example. I can remove a 2 from each of these numbers, and I could remove an X. So let's do that. So I'm going to, from each of these, remove or factor a 2x. So what I'm left with is x squared, 8x, and a minus 20. All right, cool. So now I need to think of two numbers that are going to multiply to give me 20. So there's 2 and 10, which I think could be the answer. There's 4 and 5, but I do think the answer is 2 and 10. And now I think of those possible answers, and I think it would be -2 and +10. So 2x. Then I would get x minus 2, x plus 10. So 10 times the -2 is -20. 10 added to -2 is 8. All right, cool. So C, for C, I could remove an x squared. So then I would be left with x squared minus 7x plus 10. And I need to think of two numbers again. 5 and 2 sound about right. 5 and 2 I know can somehow add to give me a -7. So this would be x squared, x minus 2, x minus 5. I really hope I'm doing this justice. What I mean is, I really hope I'm explaining this well, because it's a tough thing to teach. I'm trying to explain almost how to solve a puzzle or something. I'm trying to think of two numbers that are going to multiply to give me a 10 and add to give me a -7. So -2 and -5 will multiply to give me 10, positive 10, and -2 plus -5 will give me a -7. So I hope this makes sense. This is one of my favorite things, I think, in math, but it is a little tricky to teach. Okay, what about D? I think the GCF for D looks a bit scary. I can take a 4 out of all of these. What is 96 divided by 4? It's 24. So I can take a 4 out of all of these numbers. What else can I take? I can take at least 2 A's. So my GCF here with this trinomial is 4a squared, which would leave me with a squared minus 4. So we're going to be left with 5ab. Don't worry about the A's and the B's, not yet anyways. And then I would get, this is a tricky one. And then I would get minus 24b squared. Sorry. Okay. So, I think this is kind of it, like where we would leave this one. This one, I think we can leave it like this for now. We can look a little bit more, like once I get to type 3, we can look at figuring out D after I get to that. Because D, we do have the A's and the B's in there together, which is a little bit more challenging to factor. All right. So type 3, factoring by grouping. Any questions so far? How's everybody doing?
Good.
All right, perfect. So factoring by grouping terms. We got Mr. Lightbulb here again talking to us. He's saying Sometimes you can easily factor by setting up groups of your terms, like kind of like, I don't know how to say this, but like putting them in pairs, I guess we could say. So this one, if you look at example number 1, looks a little complicated. 3x minus 3y plus bx minus by. I don't think in real life, when you guys get to your business or medical science or engineering courses, you'll see anything as complicated as this. But I noticed that some terms have something in common. The first two have a 3 in common, and the second two have a b in common. So this one's a pretty easy one, but kind of look at how this works. So the 3x and the 3y, I can remove a 3 from. Obviously, their greatest common factor is 3. And in the second two, I can remove a b. So the interesting thing here, and what you really need to notice here, is that the terms in the brackets are the same. That's so important for doing something like this. Because the terms are the same, I can remove those terms. So that's where this comes from. You guys will see me do one of these in a minute. And I can write what's left, the 3 plus the b, to give me my second binomial. This is called factoring by grouping. Again, you'll see me do more of this, don't worry. So let's look at example number 2 here. 5a squared minus 5ab minus a 4ab squared plus 4b3. So what I'm going to do in the first term, I'm going to factor these two guys. And in the second term, I'm going to factor these two guys. And I'm going to see what happens when I do that. So in the first grouping, 5a squared minus 5ab, I can totally take a 5a away. Okay, so I get my 5a, and what's left is a minus b. Now, when I do the same thing to the second term, I'm going to remove a 4 and a b squared from the second term. I still get an a minus b. Now, there's a little note here. You got to be really careful. In this grouping of terms, I'm taking away a negative 4b squared, which leaves me here with a negative sign. 4b cubed, this guy, if I divide it by a negative, I get a negative. So you just watch your signs, be very careful. And what I end up with, as you guys will notice, is the same term in the brackets. So that's my first monomial. It says remove the common monomial. Now, my second monomial, or would this be a binomial? Anyways, doesn't matter, would be the 5a minus the 4b, what's left over. This seems a little complicated, but let me kind of show you. Maybe this will make a little bit more sense. So, for example, in number A, or letter A, I can remove a 3 here. And this would leave me with x minus 4. Okay, in the second monomial, I can remove a y. And this will leave me with x minus 4. And I kind of wish I could change my pen color a little quicker than I normally do, because I would like to write these x minus 4s as a different color. That's my first, I guess term's not the right word, but my first monomial or binomial to give me this expression. My second term is what's left over, and it's just 3 plus y. All right, let me show you one more. So let me do b. Okay, so for B, I can remove an A, and this would leave me with x plus 2. So I'm just working with this on the left here. Then in the second one, I can remove a B, and this would leave me with x plus 2. And that's not a coincidence. So my answer would be x plus 2, and then a plus b. A little different, a little unique, but I'd love for you guys to try this one. So it's 10:52. So why don't you guys take maybe 3 or 4 minutes and try C and D? You can certainly try E and F as well, but take a couple minutes and try these. Try C and D. And there is a message in the chat here. What does it say? Oh, it was Fatima giving me the answer to one of the questions. This is perfect. All right, cool. So try C and D. If you have time, you can try E and F, and then we'll look at the answers. All right, just take another minute and finish off whatever one you're working on. Some of you might have tried E and F. That's fine. But yeah, take another minute and we'll look at the answers. All right, let's check out your answers for this. So, question number C. Now, I'm a little not nervous, sorry, but like these are easy because they've been organized for you. I just want to like anybody who really is truly interested in math. Sometimes, and not in this course, I'm not trying to scare anybody, but sometimes in math these won't be in order. What I mean is these terms won't be so easy to see, but that's not for this course. I'm just saying that for like you know, any of my potential students who are going to go on and do more math. These are kind of set up to be more straightforward than they could be. So for question number C, I'm going to take away a 2. And like I keep saying take away, like I don't literally mean subtract. I just mean to factor. So I'm going to factor a 2 out of my first term. I think that's all I can do. So I get x minus 5. And then in my second terms or my second grouping, I think all I can do is take away a y. So I get x minus 5. They're the same number. They have to be. If you guys do this on a test or, you know, on the final exam, this won't be on the assignment or anything. But if you do this in the future and these terms are not the same, there's a mistake. So this, because they're the same, that's my two terms, x minus 5 and 2 plus y. All right, let's check out D. I can remove from the first one an x squared. And that leaves me, I think that's right. And that leaves me with x minus 4. And then from the second grouping, I can remove a 3, x minus 4. Yep, that looks good to me. So my answer ends up being x minus 4, and then, oops, x squared plus 3. All right, cool. Now let me check the chat. I got a lot of messages in there that I haven't read yet. Sana and Hoda, Fatima, Dustin. Yeah, that's all. That's good. All right, cool. All right, so we're almost done. I know some of you guys have a lab. I'm not sure if it's chemistry or biology or whatever. We're almost done. Oh yeah, okay. So this will be the last thing we'll do today. And I think that might be it for factoring. Let's just see. Yeah, basically that's it for factoring. So we'll do one more, well, not difference of squares, but we'll do one more type of factoring today, and then that'll be it. I'm sorry, I started a little late today. I had a meeting this morning, but let's look at type 4 and these the hardest type of trinomial. So some trinomials won't fit into the previous two forms. What that means is we need to do a little bit more work. Typically, these trinomials will have a number in front of them. Now, what do I mean? These trinomials, and I'm scrolling up for a reason, don't worry. These trinomials will look different than, say, this example. These trinomials will not have, so again, when I say trinomial, I mean 3 terms. When you see a trinomial of this form, it won't have a GCF to remove. So like, you know, looking at this example number 1, I know I can remove a 2 from all of these numbers. Looking at example number 2, I know I can remove a 5x from all of these numbers. That's called the GCF, the greatest common factor, and I can remove it. I can factor that away. These trinomials, sorry for all the scrolling, don't have a GCF. Like, look at this example here on the right of the screen. 3x squared plus 14x plus 15. There's no number I can take from all of these numbers. There's no greatest common factor. 3, 2, 5, 6. I cannot think of a factor that I can remove from these numbers. So that means I have to do something else. So step number 1, you find the product of A and C. You multiply them together. So in this example, A and C, or the first term and the last term, are 3 and 15. 3 times 15 is 45. And I'm kind of doing the same thing I did earlier. Then I'm going to find two factors of A and C of 45 that add to give them the coefficient of the middle term. So again, this is just like what I did before. Two numbers that multiply, in this case, to give me 3 and 15, so 45, but are going to add to give me 14. So this is a little bit more work, right? It's a little bit more math. Right now, this is where it gets tricky. Write the center term as the, don't worry, I'm going to show you how to do this, but write the center term as the sum of those two factors with the variable attached. So I figured out that 5 and 9, don't worry guys, I'm going to show you one of these, are two numbers that will multiply to give me 45 and add to give me 14. So what I do, and I'm here in step 3, is I split that middle term. And basically what I'm doing, guys, is I'm putting what I showed you at the beginning of class and what I showed you, 10 minutes ago, I'm putting it together. So I'm going to split that middle term into two numbers. And then I'm going to factor it by grouping, what I just did, 5 minutes ago. So step 4 says group the terms to form two pairs. Factor each pair by removing the common factor. It's factor by grouping. It's kind of what I showed you earlier. And there's a big light bulb here thing. Let me show you one. So this example says 6x squared minus x minus 15. And I know that this is different because there is a term in front of this. There is a 6x here. So this 6, this number in the beginning, means that it's not going to be a normal trinomial to factor. Okay, so first things first. Multiply the 6 by the 15. 6 times 15, or in this case, I guess 6 times negative 15 is negative 90. Now, what I need to do is solve this puzzle. I need to find two numbers that multiply to give me a minus 90, but will only add to give me a minus 1. And this is a pretty tricky example to get started with. But the answer to this is 9 and negative 10. 9 times negative 10 is negative 90. 9 plus negative 10 is a negative 1. So it works. These are my two numbers. Now, this is where it's new. And don't worry, guys. I know I'm running out of time. I know some of you have a lab to go to. I'm going to show you this, or we're going to do more of this tomorrow. But this x gets split then into those two terms. So I figured out my two terms, my two numbers were 9 and negative 10. So I split that x up into those two numbers. And then I just do what I did before. I factor by grouping. So in the first set of terms, I can take away a 3x. In the second set of terms, I can take away a 5, and I just factor by grouping like I did, I don't know, 10 minutes ago, 15 minutes ago. Well, let me do A, and then we'll stop. And then tomorrow, I promise you, I'll go through more of this. So A, okay, first things first. 2 times 15 is 30. Why am, whoops, sorry. I didn't mean to do that. I'm almost done, guys. It can be like, I don't know, 2 minutes. So 2 and 15 is 30. So I need to think of 2 numbers that are going to go together to multiply to 30 or add to give me 13. Now, like again, maybe it's because I've been doing this for years, but I can immediately think of 3 and 10. 3 times 10 is 30. 3 plus 10 is 13. So what I'm going to do is I'm going to split this number here into that 3 and 10. So I'm going to write 2x squared plus 10x plus 3x plus 5. Now, and if you're wondering why I wrote 10x and then 3x, it was just how I was feeling. It really doesn't matter. You could write 3x and then 10x. Like the order of these guys in the middle does not matter. Like, trust me, you can try this the other way. It really doesn't matter. So now what I do is I factor each of these numbers by grouping. So in the first number, I can take out 2x, and I'll be left with x plus 5. And in the second grouping, I can take away nothing. I can take away a 1. So this would be...
You can take 3.
Oh, I can take away... Oh, yeah. Sorry. Yes. You're right. I'm trying to go too quick here. This is a 15. So to the student who just spoke out loud, thank you very much. I can take away a 3 here, which would leave me with x plus 5. You could see my brain a minute ago, like kind of just breaking, because if these numbers weren't the same, I messed up, but they are the same. So my answer to this question is x plus 5 and 2x plus 3. A little tricky, and I know it's the end of the class. I've just been talking about math for an hour and 10 minutes. A little tricky, but we'll look at this more tomorrow. Don't worry. All right, so thank you, Amar, for the answer. Ooh, that's really good. Okay, cool. That's it for me today. Enjoy your lab if you guys have a lab. If there's any more questions, let me know. But other than that, that's it for me today. So have a good day, guys.
Thank you, sir.
Thank you. I hope you had a good weekend. I'll see you.
Thank you, sir.
Thank you. Thanks, everybody. Bye-bye.
So what is it?
Thank you very much.
Yes, thank you too. Perfect. All right. Thanks so much. Take care, everybody.